In this video, we will do different examples of arithmetic progression. So the first example is find the arithmetic progression if the first term is 15 and the common difference is 4. So the solution is, as the first term is 15 and our common difference, which is d, is 4. Well, as we know, the arithmetic progression sequence is like a plus d, a plus 2d, a plus 3d, and this goes on. So a is 15, so a plus d is equal to 15 plus 4. A plus 2d is 15 plus 2 into 4. A plus 3d becomes 15 plus 3 into 4. So our arithmetic progression series is like 15, 19, 15 plus 8 is equal to 23, 15 plus 12 is equal to 27. So our arithmetic progression series is like 15, 19, 23, 27, and it goes on. You can also check this by calculating the common difference. Here, the common difference between the first two consecutive terms is d1 is equal to 19 minus 15, which is equal to 4, and the next two terms d2 is equal to 23 minus 19, which is also equal to 4. So you can also check this by calculating d1 and d2. Let's solve one more example. Write an arithmetic progression whose first term is 8 and the common difference is 3. The solution is, as the first term is 8 and the common difference is 3, as we know guys, the arithmetic progression series is like a plus d, a plus 2d, a plus 3d, it goes on. So here our first term is 8, the common difference is 3, so the second term is 8 plus 3, third term, which is a plus 2d, becomes 8 plus 2 into 3, the fourth term is 8 plus 3 into 3. So 8, second term, 8 plus 3 is 11, second term is 11. The third term is 8 plus 2 into 3, which is 14, and the fourth term is 8 plus 3 into 3, which is 17. So our AP is equal to 8, 11, 14, 17, and it goes on. So you can also check this arithmetic progression by calculating d1, d2, and d3. So here the d1 is equal to 3, d2 is also equal to 3, and d3 is also equal to 3. So you can also check the arithmetic progression. Let's solve one more example. We have to find an AP whose first term is 2 and the common difference is minus 2 by 3. So here the solution is, as we know, the arithmetic progression is generally written as A plus D, A plus 2D, A plus 3D. It goes on. As our first term is equal to 2 and the common difference is equal to minus 2 by 3. So our AP will be equal to, the first term is 2, A plus D will be 2 plus minus 2 by 3. Third term is A plus 2D, which is equal to 2 plus 2 into minus 2 by 3. And the fourth term is A plus 3D, which is equal to 2 plus 3 into minus 2 by 3. So the first term will be equal to 2. Second term is 2 minus 2 by 3. Third term is 2 minus 4 by 3. Fourth term is 3 cancels 3, 2 minus 2. So the final AP is, so here we have to take the LCM, 3. 2 into 3 is 6 minus 2. Here also 6 minus 4 by 3. 2 minus 2 is 0. So our fourth term is 0. So our final arithmetic progression is 2. Second term will be equal to 4 by 3. Third term is 2 by 3. The fourth term is 0. So here if you want to check this arithmetic progression, we have to calculate T1. The first common difference, which is equal to D2 minus T1, is 4 minus 3 minus 2. And D2 will be equal to 2 by 3 minus 4 by 3. So here D1 will be equal to 4 minus 6 upon 3. D2 will be equal to 2 minus 4 by 3, which is equal to minus 2 by 3. And here 4 minus 6 is minus 2. So D1 and D2 are same. So our arithmetic progression is fine. Let's solve one more example. Find an arithmetic progression whose first term is 6 by 5 and the common difference is 1. So as we know, the arithmetic progression is written as A plus D, A plus 2D, A plus 3D, and it goes on. So here the first term is 6 by 5. Second term, which is A plus 2D, will be written as 6 plus 5 plus D is equal to 1. A plus 2D is written as 6 plus or 6 over 5 plus 2 into 1. And the fourth term is 6 upon 5 plus 3 into 1. So here the first term is 6 upon 5. Second term will be equal to 6 plus 5 upon 5. Third term is 6 plus 10 upon 5. The fourth term 6 plus 15 upon 5. So our arithmetic progression is 6 plus 5 is 11. So the second term is 11 upon 5. Third term is 16 upon 5. The fourth term is 21 upon 5. So in order to check this arithmetic progression, we have to find D1 and D2. So here the D1 is 11 upon 5 minus 6 upon 5. The D2 is equal to 16 upon 5 minus 11 upon 5. So here the D1 is 5 upon 5, which is 1. D2 is also equal to 5 upon 5, which is 1. So our arithmetic progression is right. Let's solve one more example. So we have to find the 20th term of the AP, which is written as 3, 5, 7, 9, and it goes on. So the solution is, so here in the given AP, which is 3, 5, 7, 9, A is equal to 3, which is our first term, and the common difference is equal to 5 minus 3, which is 2. As we know, the formula for the nth term is equal to A plus n minus 1d. And here we have to find the 20th term, which is A 20. So our n is equal to 20. As the first term is 3, so we will put A as 3. So n we know it is 20. And the common difference is 2. So 3 plus 19 into 2, which is further equal to 3 plus 19 into 2 is 38. So our 20th term for this AP is 41. Let's solve one more example, which is find the 12th term of the AP, which is 8, 11, 14, and 17. So the solution is, as we know, the formula for the nth term is A plus n minus 1d. Here in the given series, A is equal to 8, which is the first term. So the common difference is 11 minus 8, which is equal to 3. As we have to find the 12th term, which is equal to 8 12. So our n is equal to 12. So 8 12 is equal to, the first term is 8, n is equal to 12, common difference is 3. So 8 plus 11 into 3, which is equal to 41. So the 12th term is equal to 41. Let's do one more example. We have to find the 18th term of an AP, which is written as 18, 11, 4, minus 3, minus 10, goes on. So the solution is, so here the first term is equal to 18. So the common difference is calculated as 11 minus 18, which is equal to minus 7. So as we know, the formula for the nth term is equal to a plus n minus 1d. So here we have to find the 18th term, which is equal to a 18. So here n is equal to 18. As our first term is 18, n is also 18. So d is equal to minus 7. So 18 plus 17 into minus 7. So here 18 plus 17 into 7 is equal to 119. So 18 minus 119 is equal to minus 101. So our 18th term is equal to minus 101. Let's solve one more example. So we have to find an arithmetic progression whose first term is given as minus 8 and the 16th term is given as 52. So the solution is, so our first term is equal to minus 8, which is given, and the 16th term is 52. So in order to find an arithmetic progression, we have to find the common difference, because the arithmetic progression is written as a plus d, a plus 2d, and it goes on. As we have a, which is minus 8, but we don't have d. As the 16th term is given as 52, so we can use this to find d. As the formula for the nth term is equal to a plus n minus 1d, and here a16 is equal to 52, so here n is equal to 16. So a16 is equal to, our first term is given, which is equal to minus 8, n is equal to 16, d we have to find out. A16 is given as 52, so minus 8 plus 16 minus 1 is equal to 15, 8 plus 15d. So 52 plus 8 is equal to 15d. So 15d is equal to 52 plus 8 is 60. So a common difference is equal to 60 upon 15, which is equal to 4. So a common difference is equal to 4, and a we already know is minus 8. So arithmetic progression will be first term is minus 8 plus common difference is 4. The third term is 2 into common difference is 4. So our arithmetic progression is, first term is minus 8, second term is minus 8 plus 4, which is equal to minus 4. Third term is minus 8 plus 8, which is equal to 0. So if we calculate D1 is equal to minus 4 minus 8, and if we calculate D2 it is equal to 0 minus 4. So D1 is equal to minus 4 plus 8, which is equal to 4, and D2 is equal to 0 plus 4, which is equal to 4. So arithmetic progression is right, which is equal to minus 8, minus 4, 0, and so on. Let's solve one more example in which the 8th term is given as 46 and the 19th term is given as 112, and we have to calculate the 14th term. As the 8th term is given as 46 and 19th term is given as 112, the formula for the nth term is written as an is equal to a plus n minus 1d. As a8 is equal to 46, so for the a8 the formula will be equal to a plus 8 minus 1d, as 8 is equal to 46. So 46 is equal to a plus 8 minus 1 is 7, 7d. Similarly, A19 is given as 112. So An is equal to A plus n minus 1d. So for A19, this equation will be 19 minus 1d, A19, A plus 18d. As A19 is equal to 112, the final equation is A plus 18d is equal to 112. So our both the equations will be A plus 7d is equal to 46 and A plus 18d is equal to 112. So in order to solve these equations, we can use the elimination method. So let's name this equation as 1, as 2. So we can just simply subtract this equation, 1 minus 2. So A minus A is 0, 7d minus 18d, 46 minus 112. So 7d minus 18d is equal to minus 11d, and 46 minus 112 is equal to 66. So the d is equal to minus 66 upon 11. So d will be equal to 6. So as the common difference is calculated as 6, so we can put d in any of the one equation. Let's say we put d in the equation a plus 7d is equal to 46. So a plus 7 into 6 is equal to 46. So our a is equal to 46 minus 7 into 6 is equal to 42. So a is calculated as 4. So our first term is calculated as 4 and the common difference is calculated as 6. We have to find the 14th term, as the formula for the nth term is equal to a plus n minus 1d. For the 14th term, it will be equal to a plus 14 minus 1d. So a is calculated as 4 and d is calculated as 6. So 4 plus 13 into 6, which is equal to 4 plus 13 into 6 is 78. So it is 82. So our 14th term is equal to 82. Let's solve one more example in which we have to find the nth term of the AP, which is written as 5, 8, 11, 14, 17 goes on. And the number of terms are 12. Solution is, so here in the given AP, you can see the first term is 5 and the common difference will be calculated as 8 minus 5, which is A2 minus A1, which is 3. So here the number of terms are given as 12, so which means n is equal to 12. As we have to find the nth term, and as the formula for the nth term is equal to a plus n minus 1d. The first term is 5, n is given as 12, and d we calculated, which is 3. So 5 plus 11 into 3, which is equal to 5 plus 33. So the final answer is 38. So the nth term is equal to 38. Let's solve one more example in which our first term is given as 4 and the 10th term is given as 67, and we have to find the common difference, which is designated as D. The solution is, the first term is given as 4 and the 10th term is 67. As the 10th term is equal to 67, so we can use the formula for the nth term, which is equal to a plus n minus 1d. As a10 is equal to 67, so for the 10th term this formula will be equal to a plus 10 minus 1d. As a10 is equal to 67 and the first term is given as 4, 10 minus 1 is 9 into d. So 67 minus 4 is equal to 9d. 9d is equal to 67 minus 4, which is equal to 63. So d will be equal to 63 upon 9, as 9 into 7 is 63. So a common difference is calculated as 7. This is a final answer.